sir.
Hello, how are you doing?
I'm good, thank you. How are you?
Very good, very good. So, we did some inequalities earlier. Today, I think we can go in more details about inequalities.
Mhm.
So, we'll discuss about linear inequalities, quadratic inequalities, absolute function inequalities. We'll also take up double inequalities. So, some of these examples which I'm going to take with you will be beyond your year 12. So,
Okay.
you might get few examples which will be helpful for you for year 13. That's the whole idea, right?
All
So
right.
I thought that when we are covering this topic, why not go into greater details and understand it better, right? That's the whole idea. So let me share with you what we have for today's lesson. Okay, so there we go. So we'll talk about how to solve inequalities. Inequalities definitely means it is not an equation with equal to sign. So first thing which you have to remember is anything which does not have that equal to sign, and instead of that we have greater than, less than, greater than equal to, or less than equal to, then it will be treated as an inequality,
All
right?
right.
And on either side of this sign, you could have a linear function, absolute function, quadratic function, polynomial, or anything whatsoever. Still, it will be treated as an inequality. Perfect.
Yeah.
So I'll take a wide variety of examples, and I hope they will definitely help you for your final exams. So we'll talk about linear inequalities to start with, and also I'll discuss with you this zero test. When I say zero test, it is not a standard, but it is my way of testing your solution. So we talk
Okay.
about this, how to apply a simple test to check whether your solution is correct or not. Okay?
Yeah.
We'll take up inequalities with and or condition. Now, when I say inequalities, means we are not talking about more than one simultaneously, right? So it's a system of inequalities which we are talking about. And then we'll complicate the matter using other functions like quadratic functions, and then we'll also consider the double inequalities. Absolute functions is a big thing, especially for your year 13. So there, most of the questions involving inequalities will have a component of absolute function some way or the other. So it's a good idea to understand the whole concept, right?
Mhm.
Now, most of the time we talk about inequalities in single variable. That is to say that we are only trying to figure out what could be the value of x. Is it within some interval or it is beyond some interval? That is what we are looking at. But most of the time, that is not the case. In real life situation, we may be dealing with more than one variable. And so I thought we'll put in a few examples on two variable systems, right? And
Okay.
all the questions which I have taken during this study are related from your examination questions. So they are real questions from your papers, right? Previous test
Okay.
papers. Okay. Now, to begin with, you see here a number line which is being drawn. So how do we write our solution? So when you solve the inequalities, there are many ways to find the solution and also to write them. So one way, of course, is to put them on a number line itself. So on a number line, you can say, well, the solution is from this point to that point. Very simple. On a number line, when you're trying to show the solution, filled in circles and not fill in circles make huge difference. If
Mhm.
you want to include the boundary, then you have to fill in your circles, right? And if you do not want to include the boundary, which will be the case when I use the sign greater than or less than, right? So you don't want to include the boundary. It has to be greater than or less than, kind of, right? So in
Yeah.
this case, that circle should not be filled in. So in my diagram, so I'll show it with this white color in the center, means it is an open circle. It is
Mhm.
in. So if it is filled in, I'll make it darker. Correct? So that is one way of showing your solution. The other way is to write in the form of an inequality as such. As shown here, we are trying to write an inequality x, which is greater than 2 and less than 5. So that is another way of writing. You could also write like a coordinate point. Don't treat this as a coordinate point, you know, within the brackets 2 comma 5. It really,
Mhm.
it is not a coordinate point to 5. It means from 2 to 5.
Uh,
Both are not included, right? So that is very important to understand. If you want to include, then we use square brackets.
Square
We
brackets.
use 3 and 0, for example. I should, sorry. the other number has to be bigger, right? So 3 and 7, for example,
They,
you will use the
yeah,
square brackets. Square brackets means they are treated as
included.
circles, right?
All right. Okay.
Included. So that is how it is. Now, most important way and the common way of doing it, especially for the test papers, is writing it in the set notation. So the set notation, the curly brackets which you're looking at, these, they indicate the set of, the group of values which are the solution. So when you write this, x is the independent variable, this symbol belongs to, right? So that means belongs to the set of real numbers. R stands for the set of real numbers. This bar here gives you a condition such that, that, and the answer written there, x is greater than 2 and is less than 5. The brackets close. So that is the complete format of writing your solution. So I hope these things are absolutely clear. You know, for every solution, you have to put it in the right order to get full marks. Otherwise, you might just lose 0.5 marks for not putting it in the right order. Perfect.
So,
yeah, yes.
Just a quick thing. If in the exam, can you just write it in any form then, if they don't specify?
You are right. In any form you can write, and the simplest of all the forms, if choice is given to you, is this. Do you see that?
Oh, okay. Coordinate form.
That is the simplest form to write, and I'll prefer that if the condition is not given to you. Okay.
Okay.
That is the best way to write. So let's begin our lesson with the very first example. We're talking about how to solve linear inequalities. So we'll just take few simple examples to begin with. As I was saying, inequality really means less than, greater than, less than, equal to, or greater than, equal to symbols. But the solution of inequality is similar to that of solving any equation, with one major difference. And that major difference is written here in the caution. Can you please read what have I written here in red?
Yes, so multiplying and dividing an inequality by a negative number will also result in the reversal of the inequality sign.
Perfect.
Yeah, okay, that's important.
To give you an example, we know that 7 is greater than 5. Correct? Very clear. 7 is greater than 5. Now, when I multiply by negative on both the sides, it becomes minus 7 and minus 5. Well, minus 7 is less than minus 5. Correct? So you see a change in sign. So the sign automatically should change. If you're not changing the sign, you're solving a wrong question. Okay?
Right.
So that's kind of very important. So to begin with, I've taken here 4 examples. The first 2 are relatively straightforward. And in question number 3 and 4, what we have is implementation of this particular rule. As you can see, we have minus x over 2, and the other expression, when you open this up, you'll get a negative value for x. Now, in that case, when you multiply by a negative number on both the sides or divide by a negative number on both the sides, remember to interchange the direction of the sign also. So greater than becomes less than, and less than becomes greater than. Is that absolutely clear?
Yes.
Perfect. Now, in short, could you give me steps to solve the very first question, which is 2x plus 4 less than 10?
Yeah, so just move the 4 to the right-hand side. So it's 2x, then that same sign, 6. So x would be less than, wait, what's the sign? I don't know how to say it, but x same symbol 3. Yeah.
Less than 3, correct. Less than 3.
Less
Can you
than
give
3.
me the now solution of question number 3?
Yeah, so bring the 5 to the right-hand side. So it'll be minus x over 2 greater than 10.
Yes.
And then it'll be, so you times the 2, so it'll be minus x greater than 20.
Yes.
But we can't have minus x, so we would have to times it by minus 1. So it'll be x, and then you switch the sign. So it'll be less than minus 20.
Minus 20. Perfect. Yeah. That is what you have to do. Perfect. So you know how to solve it, and that's a good starting. So basically what we will do is, here is the inequality. You do the normal algebra thing, write down your answer clearly. So it could be written in the set form as shown here. For the second question, you just do cross multiplication first, right? Since wherever there are fractions involved, take a common denominator, multiply every term with that common denominator, so that you simplify and get a linear equation without any fractions. So once we do that, we get 2x plus 5. Now you have to take away 5 and divide by 2 to get the answer and write it properly. Correct? Now here, I would like to discuss with you how to test whether our answer is right or wrong. So for that, we have a zero test method. Correct? So there is a zero test method here. I'd like you to read what have I written here.
Right. So tips. Zero test is the fastest way to check the solution. Just substitute 0 and check if it is part of your solution or not. Substituting 0 in the first example shows that the inequality is true, and you can see that it is also part of the correct solution.
Let's understand this. So this is our first example, correct? In the first example, we are saying x is less than 3. X is less than 3 means 0 is the part of solution, correct? 0 is less than 3, right? So 0 should make the inequality true, correct? That is what it means. If I substitute 0 here, what do I get? I get 0 plus 4 is less than 10, and that is true. And therefore, we know that the answer is correct. You see that one?
Yeah.
It is. In the second example, we are saying x is greater than 8. That means 0 is false, correct? It is not true, correct? 0 is not a part of solution. Therefore, if I substitute 0 here, what do I get? As soon as I substitute 0, I get 5 over 3 is greater than equals to 7, right? Which is false, correct? False. Which is false. So that makes it clear. Do you understand? Such an easy test. It doesn't take even a second to check.
So what does that tell us then with the second one?
Second one tells us that you are saying that 0 is not a solution, and when you check, you find that 0 is not a solution. Therefore, your solution is correct.
Oh, okay. Yeah.
Correct? Because see, now it's very clear. We are saying that linear inequality really means that on a plane, a line is there. 0 could be a part of solution or could not be a part of solution. There is no parts. Either it is a part of solution or it is not a part of solution, right? Your answer is telling you whether you are saying it is a part of solution or not. In the first case, you said it is a part of solution. Then when you substitute 0, inequality should be true.
Okay, yeah.
In the second case, you are saying it is not a part of solution. That means if I substitute 0, inequality should not be true because it is not part of solution. That is what it means. So that is a very simple way of checking. Is that clear to you?
Oh, okay, yeah.
Now here we have this particular example which we have been discussing. We are now saying 5 minus x over 2 is greater than 15. And when we do all this part, we have a negative sign on the left side. As soon as I multiply by the negative sign, do you see the change in the inequality sign? It is a must. If you don't do that, you get reversed the answer, which will not be correct.
Right.
Right?
Yeah.
Likewise, in the second case also, we have a negative sign there, right? So as soon as I multiply by a negative number, I have to reverse my sign, and then we get the right solution. Correct?
Yeah.
Once you get the solution, you can always perform the zero test to see whether your solution is right or wrong. Is that clear?
Yeah.
Now, I've taken up examples regarding the I should not say double inequalities at present, but we have two different inequalities simultaneously being solved. So, can you please read this question for me?
Yes. So, example 5, inequalities with AND condition. So, find the set of values of x for which 2x minus 6 is less than x plus 7 and 3x plus 1 is greater than x plus 5.
Correct. So we have to now solve two inequalities with a condition that and the solution should fit in both. And it is to be treated like this. We have one part of the solution here, right? That is one part of the solution, and this is the second part of the solution. We have to only look for the one which is common to both. Then both are true. That is the AND condition, overlapping.
Right.
Correct? So we solve these inequalities separately. That is my first inequality. 5x minus 13 is less than x plus 5. When I solve, I get a value, which is x is less than 5, which I've shown here. X is less than 5 on the number line. Correct? The other one is 3x plus 1 is greater than x plus 5, and I got an answer which is x is greater than 2, which I've shown here as x is greater than 2. Correct? Open circles indicate that those points in the margin are not included. Those boundary conditions are given to us clearly, should not be included. So those are the open circles. Now, what is common in between the two? That is the part of our solution. So this portion, which is common between the two, is between 2 and 5. And therefore, the solution is x belongs to real numbers where x is greater than 2 and less than 5. Does it make sense to you?
Yes.
So that
and it's so clear from the number line, because you can see those are the two parts that overlap, you know?
Yes,
so that makes sense that that's the in-between region.
Perfect. It's a very difficult concept otherwise to understand, but as you was clearly saying, this number line concept, all those things really help us to understand the concept. Now here is another one for you. This is with OR condition, okay? So Amy, can you please read this particular question for me?
So example 6, inequalities with OR condition. Find the set of values of x for which 5x minus 3 is less than 7, or 2x plus 1 is greater than x plus 5.
Correct. So again, you got two different inequalities, but this time the difference is that you have OR condition, right? Either you could have apples or oranges. You just need a fruit. That is the whole idea, correct?
Yeah.
So think like this. These are your apples, these are your oranges, right? And both becomes a solution set for you, right? Either one of them. You don't want pineapples, for example, right?
Yeah.
Now, in this particular case, there could be overlapping also, right? There could be some overlapping. So if there is an overlapping, include that also. Correct?
Okay.
So either way, it is include all the solutions together, right? That is what it comes to. Perfect. So in this case, when we solve the first inequality, which is 5x minus 3 is less than or equal to 7, we get a very simple solution, x less than 2. The other inequality, 2x plus 1 greater than x plus 5, gives you another solution that x is greater than 4. On the number line, I've shown you both the solutions, one moving left of 2, and the other one, I think I wrote this value wrong, typing error, okay, right. So one moving left of 2, the other one to the right of 4. Okay, right. So those are the two intervals which are true. One for one inequality, the other one for the other one. Now, since the condition is OR, you have to include both into your solution, correct? So do you note this? So the answer should be x belongs to real numbers where x is less than 2, or x is greater than 4. Is that clear?
Yes.
Now, for OR, there is a symbol union, right? You could use the symbol union also, which at times you learn in set theory, correct? So you could be using union also, correct?
Right.
So I can also write this as in between. I could write here, instead of OR, I could write union, right? So for intersection, we have the other way, like this. For intersection, this is union. So you could use union sign also to write your solution. Is that clear? Now let's really look into double inequality. So when we talk about double inequality, means we have two inequality signs, right? In this particular case, we have something within a boundary given to us, and this time the boundary is between -7 and 9. And the function for us is 2x minus 5, correct? So now we need to consider a double inequality. -7 is, 2x minus 5 is greater than -7 and less than 9. That is our inequality. Yeah. Find the set of values for x for which this inequality is true. Second question is represent the solution on the number line. And the third one here is kind of very tricky, which says write an absolute function inequality with the same solution as above. Now, this is very interesting part, and it is a twist for many examinations, right? So many examinations will include one simple question, few parts, and some complication, and that is what we're trying to give you an experience for. So that is how your exam question may look like, okay?
Okay.
Let's begin with the very first one, double inequality. 2x minus 5 is within two boundaries, which is -7 and 9. We have to isolate x. The key idea is to isolate x. How do we do it? Well, first thing is get rid of 5. You add 5 both the sides, and the second thing is to get rid of 2, divide by 2 both the sides. I should say all 3 of them, correct? So that's what we did. So first we added 5 to everything, and then we divided 2 to everything. And we came up with a solution which was x is within -1 and 7, which is clearly shown here on the number line as within -1 and 7. So we have done part 1 and part 2. Now, so part 2 was number line thing, which we have done here, clearly shown. Now we have to look into the absolute function part. Write an absolute function inequality with the same solution as the above. Now here are very important steps to go through and understand how do we write an absolute function inequality from the given solution, right? So, Amy, the first part is clear to you?
Yeah.
Okay. Now let's understand the steps involved in writing an absolute function for the given solution. First step is find the midpoint. So we have this -1 to 7. We're looking for some value in the center. Absolute function really means from the center, how far can you be? That is what it is. We are saying we have the two boundaries at -7 and -1 and 7. We want to be within these two values of -1 and 7. Think like this. You buy some shares and you want to be within a loss of 1 unit or a gain of 7. Once you go beyond this, you would like to sell. I mean, you want to get out of it, right? So this is what you want, correct? So either the lower limit of -1 or loss of -1. That means, or a gain of 7 is good enough for you. Don't want to take more risk, and that's where you want to break out. So you have to define an absolute function for this situation. The idea is, well, what is the center value and how far are you? This is what you're going to check, right? So the points are fluctuating, the numbers are fluctuating. You're looking at the numbers and you see the number is at 3, you are safe, right? You just don't bother. But as soon as this number 3 moves towards 5, 6, you are like very, oh my God, this is the time to take an action, correct? So the idea here is to find the center value. So that is our first step. Once you are given the boundary, it has been defined as -1 and 7. The next step is find the midpoint. Add them, divide by 2. Once you add them and divide by 2, you get a critical value, which is 3, right? So you got this value of 3. Now you have to see that from 3, what level of fluctuation can you take? So you can take how much? Well, 3 to 7 is the level of 4, correct? So the absolute function is well defined. You're moving to a point which is 3 units to the right, and that gives you x minus 3 as your function. And you can tolerate 4 units. So you can be within 4. So that becomes the absolute function to define this particular value as your answer.
Okay.
Is that clear to you?
Yes.
Perfect. So that is how we have to look into it. So we find the midpoint and then take the difference from any of those endpoints. Use positive values, easy to calculate, correct? So we did 7 minus 3, got a limit of 4. We know our absolute function has moved 3 units to the right. That is what the center value of 3 is telling us. So the function is x minus 3 absolute value. And this absolute value should be less than 4 because we don't want to go beyond that. So less than 4 becomes the answer. Perfect. So treat absolute function as something from the center, how far you can deviate, right?
Yeah.
Is that clear?
Yeah.
Perfect. Now let's take another example. You can treat this as your test question. I hope you have understood the concept. The question here is, can you please read the question and answer also?
Yeah, so example 8, write inequality for given solution.
Yes.
Write the absolute function inequality for the following solution.
Correct. Solution is x is less than -2, or we have used the sign union, right? So, or x is greater than 6. Now tell me, how will you find the absolute function to represent this as your answer? Yes.
Okay, so first step would be find the midpoint between those two endpoints.
Correct.
So 6 add -2 is 4, divide by 2 is 2.
Correct.
Then you said find the distance between the midpoint and the endpoint. So
correct.
Let's choose 6 because we want to deal with positive numbers.
Correct.
So we'll do 6 minus 2, so that'll be 4.
Correct.
So the absolute function would be x minus 2, and because we're not having it within, we're not having it within, so it would have to be greater than 4,
yes,
which
away.
is
That
the
is
distance
what
we
away.
calculated.
So greater than.
Away.
Perfect.
Yeah.
Easy, right?
Yeah.
That is how we should be doing, right? So that is the strategy. So I sometimes say like this: where can I move so that the fish market is 4 kilometers away from my home? Just to remember, right? So this is an absolute function. I could be either north, south, east, or west of that particular fish market where I don't want to be, right? So I want to be away. So that is that greater than sign which signifies. Is that clear?
Right. Yeah.
Okay. Next example is we're now jumping into the quadratic function inequalities. So here is one simple case. There could be 3 scenarios when you work with quadratic functions as shown here. So let's take up these examples one by one and we'll actually understand how to solve them. This could be part of your solution later, but to begin with, we have to understand the concept. First example, x squared minus 1 is less than 0, right? So less than 0 means a negative value, correct? Less than 0 means negative value. So we are looking into something which is less than, that means negative value. And whenever it says less than, we are also saying within. Do you understand? Within. So that also gives you a good idea. Now, this concept of within only works if and only if the leading coefficient is positive. Do you see this is positive, not minus x squared, right? As in a parabola. If I write minus x squared, the parabola is going downwards, right? The things change. Perfect. So the concept which I'm talking about, keep in mind that the leading coefficient should be positive. So make a note of this. Leading coefficient positive. Now you have freedom of, making the leading coefficient positive. Do it at the first instance.
Okay.
You understand?
Yeah. Otherwise, the rules won't work and things.
The rules will not work. You'll get confused. No point, right? So keep that positive. First thing. Now, fortunately, in this particular example, it is positive. So we take 1 on the other side and we land up with a very simple equation: x squared is less than 1. Now, what is square root of x squared? Tell me, Annie.
Square root of x squared.
Yes.
X.
No.
X plus minus x. No. Plus or minus x.
Square root of x is absolute value of x. It is always positive. You remember?
Oh, because anything squared is positive.
Yeah. So the square root function is always in quadrant 1. So many times I've seen this particular mistake. They just write x. Square root of x squared is not x. The absolute value of x, and that is the reason why I introduced you to absolute value of x before getting into quadratic functions. It's so closely related, so we can't really, go without it. Perfect. So remember, when you have to solve this inequality, you have to do square root on both the sides. Once you do that, square root of x squared is not x. It is absolute value of x. If you write x, then your solution will be x is less than 1, which is wrong solution.
Oh.
Correct?
Yeah.
X is less than 1 is not the right solution, correct?
Yeah.
Absolute value of x. You get the idea now. Now
how
we
come
are
it's
saying,
not, sorry, how come it's not plus and minus 1 when you square root 1?
You could do that. But then in inequalities, when you do minus, you have to reverse the sign. It is so complicated. When you do minus, you have to reverse the sign. So now all of a sudden, you'll think like, when are we doing minus? When are we doing plus? It is such a difficult question to figure out. So absolute function is the solution. So many students, what they do is, they do this step in a different way. At this particular point, they will write like, guess and check. They'll write x is less than 1 and x is greater than, I don't know, minus 1 or whatever, right? Minus 1, correct? They will write, right? Do you understand what I'm trying to say here? Is that clear to you?
Wait, so
at this stage, they will say x is greater than, less than 1, I should say. Again, I'm myself getting confused. And the other one is x is greater than minus 1. Because when you introduce the negative sign, you have to flip the sign, inequality sign.
Right.
So it was originally less than. So with positive less than is fine, okay? But with negative, you have to flip the sign.
Oh, yeah. That makes sense.
It's too complicated. Even in a simple example like this, it's difficult to work on. Therefore, I'll prefer you to understand square root of x squared is an absolute function and then move from there, right? So we have absolute value of x is less than 1. That means it is within the limit of 1 and minus 1, correct?
Yeah.
So you can straight away write this as we learn x is within plus 1 and minus 1. And you can see here clearly in the diagram shown that it is the graph below the x-axis. Perfect, clear? So everything like sinks in. So that's the reason why I have taken a very simple equation, a trick involved in the middle, and then the graph to show you the effect, right? So you can clearly see that that is how we are going to solve quadratic inequalities. Is that clear to you? So
do you mind?
Yes.
Oh, sorry. Do you mind, you know, with the absolute function,
yes.
You know, when you do that piecewise thing, like,
yes.
how do I know it's in between 1 and minus 1? Could you just show it like there, just to double check?
Okay, sure. So when we say absolute value of x, it is basically equal to x when x is greater than equal to 0. However, it is equal to negative of x when x is less than 0. Simply because when you get into the basics of parent functions, you know a straight line is y equals to x, right? So if I draw a straight line, this is y equals to x.
Yeah.
Okay? Now, if I have to write the absolute value of x, I have to flip this and make it positive. That means negative of negative is positive, right? So, so on this side, now when I do this, it becomes absolute value of x. So that is what I mean when I write this statement. That is on the negative side, the line has to be flipped, and therefore I'm taking the negative x value. Do you understand?
Oh, okay, yeah.
So it flips. And therefore, when I was looking into this particular interval, where I was good with positive one side, but when I go to the negative one side, the absolute function value has to flip. And so I have to make the negative sign. Correct?
Oh, yeah,
It's a very simple process to understand now at this stage. However, when you have a tricky question, which could be something more complicated than this, it becomes very difficult to work with. Okay?
Right.
Therefore, understanding the absolute concept directly and writing your equation from square root of x squared equals to absolute value of x helps.
Oh, perfect. Okay. That makes sense now.
And now we are saying this absolute value is within, that means plus and minus value. Within, do you understand? Plus and minus value, that one. So within this plus and minus value of 1, and that straight answer. Got it?
So you got the plus and minus 1 from just subbing in that piece. Okay, yeah, got it.
That is the meaning of absolute value of x.
Oh.
So we applied the definition of absolute value of x to get to our answer. Clear?
Oh, okay, yeah.
Let's take the next example, which is 12 minus 3x squared is less than equal to 0. So to begin with, you will think less than equal to means within, right? And then you'll start your work.
Yeah.
However, remember, there is a negative sign here. So we have minus 3x squared. And so when you multiply by the negative sign, we have to flip and it becomes greater than equal to 4. Do you see that part?
Yeah.
As soon as we have that, and the next step is our critical step, let me highlight with orange, which is absolute value of x is greater than equal to 2, since when you do square root of x squared, it is absolute
x.
So we get this part of absolute value of x greater than 2 or equal to 2. That means 2 is included in your solution. It is a solid circle. It is included. Is it okay? And you're going away 2 units from 2 units, like a fish market. You are going away from that fish market. And therefore, we have this particular answer shown there. X is less than minus 2 on one side, or it is greater than 2 on the other side. And that becomes your solution.
See, that's the bit I didn't get. So when you get to the absolute value, you get it greater than or equal to 2.
Yes.
If I sub in 2 into like, so that'll be 2. So I know it'll be 2 and minus 2. How do I know which way the signs are? I know it has to be away.
Okay.
So
if you write x as minus 7, If you write x as minus 7, in that case, it becomes 7. 7 is greater than 2 is true, correct?
Yeah.
Now, to answer your question correctly, you remember the zero test?
Yep.
Apply
Sub
0.
in 0.
Now, when you sub in 0, absolute value of 0 is also 0, right? Now, the question is, 0 is greater than equal to true is false, right?
0 is greater. Yeah.
It is not a part of solution.
No.
That is true. It is not a part of solution. Solution is away from 0.
Yeah.
You get it?
So it should be greater than or equal to.
Yes,
okay.
outside. Do you understand?
Sub in
0, get your solution. In this particular case, if I write 0, I know 0 is within plus and minus, and so it should be included.
Okay.
0 test. So if you are confused about it at any stage, perform 0 test. Very simple. 0 is either a part of your solution or not.
Perfect. Okay.
Perfect. Correct. So last example here is 4x squared plus 1 is less than equal to 0. Now, when you solve this particular equation, what do you get, Amy? You get 4x squared is less than equal to minus 1 when I put that 1 on the other side. Well, these are all positive quantities. X squared is always positive, 4 is positive. They cannot be less than 1 minus. Right? They're never negative, and therefore we have no solution. To represent the situation, you know this particular parabola here, right?
Yeah.
The parabola is above the x-axis. It is not going below the x-axis. There's no question of going below minus 1, and therefore there is no solution.
Oh, okay.
Yeah.
Yeah.
Even if you do the absolute value function, correct? So first thing is, when you do square root of minus 1, you get imaginary number, which is not defined, and therefore it has no solution, right? You could do that also directly from here. So in a quadratic equation, inequality, I should say, there are 3 scenarios. You may get a solution, you may not get a solution, you may also get 1 solution or 2 solutions, okay?
Yeah.
But remember, when we are talking about inequalities, it's a good point we are stumbling upon now. I should have told you earlier also. Whenever we are writing solution of an inequality, it is not a point, it is a region, area. So we are saying everything within, do you see that? Everything within, it is infinite number of points within minus 1 and plus 1, which we are talking about, correct?
Yeah.
Everything outside, right? So it's a area. Everything outside is a part of solution. Is it clear?
Yeah.
That is what a solution will be for us. It's not just a point, okay, or 2 points. Now, moving forward with more absolute functions, since you are showing some doubts about it, so I just took this, fortunately, an example which can probably clarify most of your doubts. Example 10. We'll explore absolute function inequality now. Explore different situations with absolute function inequality. Let's discuss them one by one. The very first one is absolute value of x is less than equal to 5. What do you think should be solution for that, Emmy?
So, okay, so it's less than or equal to. So we know it has to be within 2 values. So it has to be 5 or minus 5.
Perfect. So say minus 5 first. So it has to be between minus 5 and 5. Yeah, let's get into right nomenclature also. Perfect. Okay. And as shown here clearly, both 5 and minus 5 should be included. Solid circles mentioned there on a number line. And also you could write this inequality as your answer. And the next one here is absolute value of x greater than 3. How will you write this as your solution?
So since it's greater than, we know it has to be away. Okay. So we want it outside. So what we will have is x being less than minus 3 and x being greater than.
Or. So the key word is or. Not and. And will mean you want to have a combination. Here, there is no common point, no solution in that case. So do not write and in your answer. You will be deducted 0.5 marks for just writing and instead of or.
Okay. How come it's less than or equal to minus 3? Not just less than minus 3. How come minus 3 is included though? Why can't it not be?
Oh my God, yes, that's a typing error. You're so right.
Oh, that's what I was stressing out. I was like, I don't get this.
No. Oh my God. So I do sometimes a lot of typing errors. It should not be included. Oh my God, you're right. Yes.
No, so now that makes sense, yeah.
X is less than minus 3. Right. It's an open circle here, okay?
Yeah, okay.
Perfect. Thanks for correcting that.
That's right.
Yes. Now the next example here is absolute value of x plus 2 which should be greater than equal to 5. In this particular case, how are you going to solve? Can you please tell me?
Okay, so okay, let's start from the basics. So we know it's greater than or equal to, so we know it has to be away.
Away, that's correct. Very good.
Yeah, and then okay, so we know when we were dealing with the absolute function of x,
yeah,
we know it's at the origin. So the cusp corner is at the origin. But I remember obviously doing graphs with you. When it says +2, we move the graph 2 units to the left.
Correct.
Yeah, and then we work from there. So do it like a normal equation, and when you move the -2 to the -5 minus 2 would be x less than or equal to -7.
Correct.
And then or x greater than or equal to 3.
Perfect. So that is how you have to visualize. Now, clear, to do it algebraically, very simple steps. We know it is greater than equal to, that means you are going away. Away from what? 5 or -5? Because we're talking about absolute value, right? So we're going away from 5 or -5. Obviously, when you're going away from -5, you're going lesser and lesser. When you're going away from +5, you're going more and more. And so we have our equation that the function x plus 2 should be greater than equal to 5 or less than equal to -5. Make sense?
Yeah.
You're going away. And once you have those two simple linear inequalities to solve, you can easily find your answer and combine it, because the condition is or, correct? Combine it to put it as a solution. Is that clear to you?
Yeah.
So now here is an interpretation. Interpret as within when you have less than sign, correct? Include the boundary if you have equal to combined with it, correct? In this case, interpret beyond when we have greater than sign, and do not include the boundary because that equal to sign is not there in this particular case, correct? In the last case, we have x plus 2. That means we have to move 2 units left and then beyond 5. Do you understand? And then beyond 5 and include the boundary. You could think like this. It helps you to find the solution. Clear?
Makes sense. Yeah.
Perfect. Now, keeping that in view, here is a test question for you on absolute function, which is similar to our third example. Can you please read the question and answer?
Yes. So, so example 11, absolute function inequality. Solve the absolute function of x minus 3 being less than or equal to 7. Hint that less than value of absolute function implies within a defined boundary. Yep. So so that's what I was going to say. So since it's less than, it'll be within, and both it'll be defined boundary because it's equal to. So we simply know, like the previous one, we know it's in between 7 and -7.
Correct.
And like I remember ages ago, you did the similar question like this. So we're trying to isolate x. So we add 3 to all the sides. Yep. So you get -4 less than or equal to x, and then less than or equal to 7.
Simple as that. Perfect. So the simple as that solution. Now, many students will go with the definition of -3 absolute function. They may write this as a piecewise function and then solve as 2 different inequalities as shown there. So we have also provided with you an alternate solution, right? Okay. This is the next question actually. Okay. No, the same one, right?
Wait, is that one the way you solved it? The one that was in question 10, the last one?
Yeah.
Oh, no, okay.
Let's go back to question 10. In question 10, we had a very simple case. We solved it directly, correct? We took very simple cases, and by definition, we solved it. Is that clear to you?
In part C.
Pardon?
In part C, is that also by definition?
By definition.
Okay.
So in part C, we are saying beyond 5, that means left side of -5 and right side of +5. Simple.
Right. Okay.
So yes, I explicitly didn't say that. So the same function here is on the left side of -5, and the same function there is on the right side of +5. And so you got your solution. Clear?
Yep.
This is a very good approach to solve. Now, once again, we have a different example, but similar, but with x minus 3, less than. Less than means less than equal to within, right? So put the same function within plus and minus 7 and you get your solution, correct?
Yeah.
Now, let's look into difficult ways of solving the same thing. One, we understand in a particular graph, x minus 3 means moving 3 units to the right. And less than means 7 means that you are, from this particular point, you are 7 units away. Do you see that? That's what it means.
Yeah.
So from 3, if you go 7 left, you will reach a point which is minus 4, correct? And from 3, if you go 7 right, you will reach a point which is 10. So you can visualize that as your solution. Perfect?
Yeah.
Now, here is how we can actually also solve. This is the alternate method. Let me write down here, alternate. Now, this alternate method will be used when we involve more than one absolute function inequality, right? So we are still dealing with a very simple case when we have only one absolute function inequality. We could do with some definition and some concepts as we are doing it, correct? However, what we have to normally do is we have to split the definition, our function, into two parts, right? As you can see here, one is the positive value, the other one is the negative value of the linear function being treated, correct?
Yeah.
So we have this particular function which is inequality, which is absolute value of x minus 3 is less than equal to 7, right? So that really means that if I'm treating a region which is on the right side, correct? In that case,
greater
this has to be
greater than or equal to.
Yeah, greater than equal to, because I made minus, right? So now look at it like this. So either you have a negative value or you have a positive value, correct? You are either dealing with negative portion or you're dealing with the positive portion of it, correct? So
right.
The negative portion of this when the x value is less than 3. So this is the interval. So I mean, when x value is less than 3, you are working in this area, correct? In that particular case, the negative of x minus 3 should be less than or equal to 7. Do you understand? So we flip this side.
Yeah.
But if you're working in the right side, then you keep the function as such. X minus 3 is less than equal to 7. And then you solve both the inequalities. Perfect? So when you solve both the inequalities, then you are getting a solution. One solution is that x is between minus 4 and 3. The other one is that x is between 3 and 10. When you combine these two solutions, we get our final solution that it is between minus 4 and 10, both values included. Right?
That seems longer.
Much longer, very complicated. But I hope you have understood the concept, and that concept helps you to get the answer in 3 statements.
Yeah, but it's really good to know that one, because what happened if you made an error in the really quick one? This one, you won't go wrong.
Yes. Well, this method will be required later for more than one function.
So you can't use that one?
That'll be too complicated. Because then there will be some different regions where we may have to use positive or negative values. Is that clear? So we may have to divide into regions and do if we have more than one function. Is that clear to you?
Okay, yeah.
If there was only one absolute function and we could do it by method 1, right? That is preferred. Perfect, right? But if there are more than one function, which we'll take up in the next lesson. More than one function, how do we do? In that case, we'll do method 2. Is that clear to you?
Yep.
Let's call this as method 1 for one function, more than one method. Okay, so we are going to end our lesson with the last example on absolute functions. Okay?
Yeah.
So can you please read example number 12 and help me solve it?
So example 12, consolidate absolute function inequality.
Right.
Solve the absolute function 2x plus 3 being greater than 9.
Yes.
So greater than for absolute function implies away from the defined boundary. Right.
Okay. Right. So let me first give you a big picture, right? So definitely from here, if you look at this function, we have translated left, right? That means left, right? Translated because that moves to 3/2.
Yeah.
So that is one part. Second part is the y value, which is 9. So this is your line, which is y equals to 9. Is that clear to you?
Yeah.
This is the point where the vertex has moved to the position 3/2. Is that clear to you?
Yeah.
Now, what we are trying to say here is, once you do this, then the point of intersection, whatever it is, right? Since we have only greater than, so these are the circles, right? At the point of intersection?
Yeah.
Greater than means away. So when you graph it, go away. On the graph, you get your solution so easy. You see that part.
Wait, how did we get those 2x values?
Which, these two?
The ones you circled.
The ones, okay, let's go again. Let's go.
Yeah, what does it say?
Yeah, it's too small. So first part is, we have a function which is 2x plus 3, correct?
Yeah.
When is it equal to 0? This is what we're trying to figure out. So we say 2x is equals to minus 3, x is equals to minus 3 by 2. Point where there is a vertex is at minus 3 by 2. This is the only value which will give you 0 here, right?
Yeah.
So at 0, we have a vertex. Is that clear to you? That means
yeah.
on the number line, correct? Y value is 0. Now, the second part of the equation is, now you could actually sketch this particular function. So 2x plus 3 is a line, correct? So you could actually take some x values and you can sketch the function 2x plus 3 on a graph. So take some values of x as, let's say, minus 2, because the 2 is the denominator, I'll prefer to take values like minus 4, minus 2, 0, 2, and 4, correct?
Yep.
Substitute and get y values. Once you get y values, you have sketched the graph of this particular function. So you get this graph.
Oh, okay.
Is that clear to you? So you make the graph, right? Because we are getting into an exact answer. Earlier, I was giving you quick steps to think and write the answer, right?
Yeah.
Now, we have another function which is y equals to 9. This is the y value of 9. Is that clear to you? Y equals to 9 is a straight line. And we are drawn dotted line. Do you see this dotted line here?
Yeah.
Means not included. Dotted means not included. So wherever it intersects, we get these x values. So brought them down on this. These are your answers from the graph.
Oh, yeah. I thought you went from the number line to the graph. That's why I got confused.
From the graph, we came down. So we have a point here. Since it is only greater than circles, open circles, not included. And also the function is greater than means going away. And therefore we have a solution which is going away in both the directions. Is that clear to you?
Yep.
So that is a visual look at the solution, what we're trying to figure out. Is that clear?
Oh, okay. Yeah.
Your question was, how do we get these x values, right? Which, let's say, x1 and x2. For that, we have the algebraic method. Either you do graphically, accurately graph and then get the points, right? Or you do algebraic method. Now, we will now discuss the algebraic method which can be followed here using intervals, right? You could always solve this as we did option 1. There is still one function, correct? One function you could solve very easily, saying that 2x plus 3 is greater than 9. This is one equation. And the other one is
less than
2x plus 3 is less than minus 9.
Minus 9.
Correct?
Yeah.
These two equations, you'll get your solution, which will be exactly as written here in the answer. Right? Take 3 to the other side, it makes it 6. Divide by 2 makes it 3. So you get x greater than 3, correct?
Yeah.
That gives you x greater than 3. And this one, take 3 the other side, minus 12, divide by 2, minus 6. So x is less than minus 6. So you get the other answer, x less than minus 6. So very easily with one function, method 1 works.
Yeah.
But this is a simple example to teach you the method which is complicated. So we are going to do is we'll redefine piecewise function.
Piecewise function. Yeah.
Absolute value of 2x plus 3 basically is equal to negative of 2x plus 3 when x is towards the left side of that vertex, which is at minus 3 by 2.
Wait, so I thought I had it, but then I lost it again. So I get that x equals minus 3 over 2. It's just which way round the signs go when it's minus and...
So when you go left side of minus 3 by 2, it becomes negative.
Negative. So it has to be less than.
Yes, less than. When we are defining the function itself, the inside part we are defining, okay? And when you're on the right side of minus 2, it remains as a positive line because you never flipped it, right? So you can see this part of the line was not flipped. However,
yeah,
the line which was flipped was on the left side of the vertex, which is at minus 3 by 2.
Yeah.
So
but
we redefine, yes.
Yeah, but I don't get how with the positive 2x plus 3, why is it not just greater than minus 3? Why is it greater than equal to?
No, we are not defining the function. We are saying interval. Within this interval, which is the right side, our function is 2x plus 3. So what we are saying here is this. Let me clear this space and I'll write down. So what we are saying here is that in this interval, the function is 2x plus 3.
Yeah.
But on the interval on the left side, it is minus of 2x plus 3.
Yeah.
So that is what I'm trying to say. Correct? And that is what is defined here. Do you see that minus?
Yeah. Yeah. It's just the sign. So like, I get that it's less than because it's the left side and we're going negative. Yes. But then with the right side, it should be greater than. But I don't get why it's greater than equal to. Why can't it just be greater than?
Okay. You have to include that vertex at some place. Either you could include on less than side or on the right hand side.
Oh, see, that's all I needed. That was the point.
No, I see. It is not a typing error as it was in the last time.
Oh, okay.
Yeah.
So you have to include it on either one of the sides.
Yes.
I see, I didn't know that.
Correct. You're right. So basically what we did was we redefined a function. So this is the interval when x is greater than equal to minus 3 by 2. And this is the interval when x is less than minus 3 by 2. Within that interval, we'll solve our linear inequality. That is the question.
Yep, perfect. Okay, that makes sense.
So we have the function. So substitute this particular function instead of absolute value. Is that clear?
Yeah.
So now we have substituted the function. So we get, instead of absolute value, we get negative. I wrote directly. You could do directly like this also. Correct?
2x
plus 3 less than minus 9 is a better way of writing directly. You could do that. Correct? So the function was minus 2x plus 3 because we are working on the left side of our vertex.
Yeah.
That is the interval, right? So you have to remember, when you get the solution of this, you have to include that it is only within that interval, right? If you get beyond that interval, don't take that as your answer. Is that clear?
Okay. Yeah.
When you solve, you get a value which is x is less than minus 6. And since x is less than minus 6 and the interval is less than minus 1.5, everything is in your solution, correct?
Mm-hmm. Yeah.
That is one part of our solution for the left side. For the right side, when x is beyond minus 3 by 2, in that case, we again solved it. We got x greater than 3. And so that becomes another part of the solution. Combining the two with OR condition, we get our answer.
Perfect. Yeah.
Is that clear to you?
Mm-hmm. And that makes sense because originally when we started the question, we said greater than means beyond the boundary, but yeah, so and not including like the defined like boundary. And our answer shows exactly that because we got the OR and it's not like equal to sign, so it's all right.
Correct. So, I mean, I hope that makes sense. We started with a lot of concepts to begin with.
Yeah.
And, there are many more things to go. So we did almost up to this place. We did take some of the quadratic inequalities, but I hope with this, we have learned the whole concept of it. We will actually do some more exam review questions, right? We'll do some more exam review questions, and we'll also take up nonlinear two-variable systems with additional absolute functions in our next lesson. Is that clear?
Oh, okay. Yeah.
For now, do you understand the concept of solving inequalities?
Yeah, that was quite intense, but like, yeah, it's good to go through it thoroughly because now it's like really clear in my head.
So can you now summarize me what have you learned about the solution of inequalities?
Yeah, so with the linear inequalities, quite simple, just do it like an equation, pretty much solve it. Key thing is when multiplying or dividing by a negative number, remember that the sign it flips, it reverses, so don't forget about that. And then zero test. So what we do here is it's the fastest way to check if there is a solution or not. So you simply sub in zero into the equation, and if it works with the inequality, it means it's true and we got our answer. That's how you check it. And obviously if you put it in and it's false, then that's also, then the solution is, well, it's true based on what you've like done. So that's like a very good test to do because verifying your answer is critical. And then inequalities with and condition means, so you've got the two inequalities, and since it's and, it means it's union, like, no, not union, in the Venn diagram graph, you know, where it overlaps, that part. And then the inequalities with the or condition means the union, so the U, and it's either one or the other. And don't write it as a one group thing because that would be completely incorrect.
Perfect.
They have to be done as two separate things. Then we touched upon the absolute functions.
Yes.
Yeah, we did.
We did. Yes.
Yes, because you highlighted a different color. Okay.
We'll do further on this.
Oh, okay. So yeah. So what we did though today was just learning about, like, because I haven't even like, it's not in my curriculum for year 12, so I needed a bit more understanding the basic concepts on that, which we did today. So I understood, for starters, the square root of x squared is the absolute function of x.
Perfect.
The absolute value of x. Yeah, so that was important.
One of my most popular video. What is square root of x squared? It is absolute value of x. It is one of my most popular videos.
Yeah, don't say x.
Don't say
remember. Yeah, and the absolute functions, we dealt with the piecewise functions. So doing the positive being greater than 0, and then doing the minus of that function being less than 0. We showed it through the graphs and everything, which was very visual for me. And knowing, this was a key rule when doing, like when it says within, it has to be less than, and then when it means like beyond the boundary or away, you have to do it greater than. But this rule only works when the coefficient is positive.
Yes, for quadratic functions. That is so true.
Quadratic functions, yeah.
So what you're trying to say is right there, right? So in this particular case, when we are trying to use this rule, make sure that the coefficient of x squared is positive. So the graph parabola is opening upwards, and then you apply these simple rules to get to your solution. That is so true, right? That is so true. So I guess you got most of the concepts. Some more, intricate examples, which are, I should say, level A on inequalities. We'll wind up this lesson in the next class. So I'm going to take up multiple examples on absolute functions where we are going to have more than one absolute function. And so this technique, which looked slightly complicated today, dividing into different regions and then solving, you'll find it effective when it is a complicated question involving more than one function, right?
Okay.
It is not only an absolute function, it could be absolute function combined with other functions, right? So those things, we'll take a few. That will give you a clearly very good idea. And then I think you'll get, you'll be able to do all the questions up to whatever, A level, whatever you want, right? So for your particular year 12, I think we have already covered all what is required. So at this stage, I'll request you to do all the questions from your notebook. And then if there are any questions for me to answer, let me know so that I could include them into my next lesson. And that should be good, right?
Okay. So thank you so much, sir. I really appreciate it.
My pleasure. My pleasure. Okay, then.
Have a good rest of your day. Thank you.
Thank you.
Bye.